Scale drawings is a lot like the other topics we've learned in solving proportions. Scale drawings has a lot to do with maps. It has a lot to do with small things that are scaled down from the actual size. And that's where the scale is going to come into play. Now, the most important thing with scale drawings, just like a lot of the topics, is the setup of the proportion. If you properly set it up, the actual solving, the cross multiplying and dividing, is the easy part. So a lot of our energy is going to be spent in the setup part. Keep in mind, they are going to ask you to find the area and the perimeter in some of these instances. So we'll briefly review area and perimeter, and then we'll get a little bit deeper into using the scale to put in our proportion and solve by cross multiplying and dividing. Area and perimeter is a fairly basic concept, but just to review to make sure we all understand how to do it. The perimeter is a measurement of the distance around the outside of an object. I have a very simple rectangle here with both the length and the width labeled, and I'm simply going to add up each length of the four sides of this rectangle. Now we know in a rectangle that opposite sides are congruent, so if this is 5 feet, this is also 5 feet. So it's 5 plus 12, which is 17, plus another 5, which is 22, plus another 12, which is 34. So the perimeter is 34 feet. You also could have added 5 plus 12, gotten 17, and then doubled that, because whatever this is on here and here, it's going to be twice that when you incorporate the other two matching sides. So the perimeter is equal to 34 feet. You need both the length and the width, obviously, to do that. The area, which is always measured in square units, is how many squares are the inside. So you're kind of almost making a multiplication matrix where this is made up of 12 different sections because there's 12 in them, and this is made up of 5 different sections. So when the grid gets through, it's as simple as counting, or you multiply 5 times 12, which in this case is 60. But it's not just 60, and it's not 60 feet. It's 60 feet squared, or 60 square feet, which is the area of a rectangle. Note that when you do these upcoming scale drawing problems, you will not be given the actual dimensions. You will have to find them first and then do the calculations that we just did. So you will use the proportion to find what the numbers are, both the length and the width, and then you will use them to find either the area or the perimeter or both. So when we talk about a scale drawing, we're saying some very, very big or very, very small things are drawn so that the human eye, can see it a lot better. Some examples, the most common example is a map. Believe it or not, the United States is not actually this small, but if you zoom in on the map and you wanted to see like the actual outline of any given state, it is the actual outline. It's drawn the correct way, just much, much smaller than it should be. So it's drawn what's called to scale. Now, if you look at any map, you can actually see, and this one is down in this bottom corner right here, it says that this length is 200 miles. So if you measured this length anywhere, so like from there to there, let's say, that's not like, 1.5 centimeters, that's 200 miles in reality. So it shows you a scale, and we're going to use that same scale. Might also talk about insects. Believe it or not, insects are not actually this large. But again, this picture, any photograph, is either bigger or smaller than it actually is. Otherwise, it's called life size, like the actual size of it. This is a zoomed in portion of what it looks like. This is drawn to scale. So like the ratio of the head to the abdomen, it's all the same, the leg length. It's drawn correctly. It's a photograph. It's just obviously smaller. So we have to scale it up or scale it down. And then, blueprints of cars is another thing where cars are not actually this small, but the ratios, the dimensions are the same. We have to figure out what the actual size is, and we use a thing called the scale. So no matter what, with something that's drawn to scale, the key is that actual scale. And they'll give you the scale, otherwise you can't figure things out. That scale in this example of a map of New York is 1 inch is actually 50 miles. So the key to this is still going to be the setup of your proportion. Example A says from the red dot, which is Smithtown, to the blue dot, which is Binghamton, that in the map is 6 inches. So what is the actual distance? Remember that in a proportion, there are 4 blank spaces, and there are 2 numbers that are automatically connected. The 2 numbers that are automatically connected go into one of the 2 fractions. In this case, it's pretty obvious what are the 2 connected numbers because it is the scale. Just as with anything, you could put them anywhere you want. You could put 1 inch and 50 miles, make sure you're labeling there, or you could flip it around and you could put that entire thing on this side, or you can flip it upside down and put 50 miles on the top and 1 inch on the bottom. If you'd like, you can do that. It doesn't matter as long as when you get the new piece of information, 6 inches, so the option of the numerator or the denominator, you have to be consistent. It goes with the other inches. That's why we're labeling 6 inches. And to solve, we again cross multiply. 50 times 6 is 300. In this case, we divide by 1, which is still 300. Now, what is it? 300 what? 300 days, 300 feet. Well, since miles was on top, again, it's 300 miles is the answer. Every other example is simply using the scale on one side, making sure you're labeling, and sometimes it'll be the same thing, so you have to kind of pay attention. Like it'll be the same both feet and feet. It'll be a small feet and then a big number of feet. But make sure you're labeling to help you out and just be consistent. Make sure you're using your brain, your logic to determine if the answer is correct. We did another quick example. Set up a proportion. Again, I'm going to flip this around. I'm going to put 1 inch on the numerator on this case and 50 miles on that case because it's still the scale, so they go together. This time 3 inches. Since inches is on top, I'll put 3 inches on the top there. This time again, it's 3 times 50, which is 150. Divided by 1, so the answer is 150. And this is, again, miles. Make sure you're labeling 150 miles. Another example with a blueprint. Here, when you find the scale, you know that those 2 numbers go together. I'm going to put them on this side, 2 centimeters to 5 feet. That's my scale. The question says from the bed to the dresser is 3 centimeters. As long as you label, it's pretty obvious. You just put it up top with the other centimeters. Cross multiply. 3 times 5 is 15. Divide by the leftover 2, which is 7.5. And it's 7.5. The missing part was feet. So the answer is 7.5 feet. As long as you have that scale, you just plug in, and then it's easy from there. Last 2 questions we're going to do. These are the types of questions they're asking you in Edmentum. Right at the top, it says the scale. This is the thing I need to pay attention to. 3 inches is 500 feet. Find the actual distance. On the map, the length of a basketball court is 2 inches, and the width is 1.5 inches. What's the actual area and perimeter? So this one is a multi-step problem. I'm going to draw the map picture of the basketball court. This is 1.5 inches, and this is 2 inches. This is the map, but I'm going to find out what the actual length is by using my proportion. I know, based on the scale up here, 3 inches is the same as 500 feet. So it says that this is 1.5 inches, so it's 1.5, and this is x. When we cross multiply, we divide by 3, we'll get an answer of 250 feet, which obviously does not make sense for this problem, but we're quickly setting one up. So this is actually 250 feet. That is the length. Now, that's the width. The length, which is 2 inches, we do the same proportion. We'll set up again. I'll do a different color so you can see it. We still use the same scale, which is up here. 3 inches equals 500 feet. We could put it in the same spot if we want to be consistent, 500 feet. And this time it's 2 inches being consistent. We label in both instances, inches, 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 inches. We cross multiply and we divide. In this case, we get 333.3 repeating feet. This is actually 333.3 repeating feet. We're not done at all. 250 feet and 333.3 repeating feet are not my answers. Those are just the dimensions. Now, if we remember our review of area and perimeter, to find the area, we would multiply 250 times 333.3 repeating, which is not going to be the greatest answer. We'll do 250 times 333.3 repeating, and we get the area is equal to 83,333.3 repeating feet squared. Remember, area is always squared. And the perimeter is, we add up 250 plus 333 plus 250 plus 333. So we get, when we add those all up, 1,166.6 repeating feet. Again, not actual answers. It's a really big basketball court. Maybe it's a basketball court for giants of some sort, but that is how we would find the area and perimeter for a rectangle given a scale. The last question is if they gave you something different. In all the instances, we've done what was given on the picture, but we can determine using the same scale, what if this actually was 600 feet? What would it be on the map? Well, it's not that much more difficult. You just plug that in, matching up based on our labels, and then we still cross multiply and solve and get our actual answer. Please don't do, oh, add 100, so it's 100. Remember, there's no adding in proportion. It's all cross multiplying and dividing. Multiplying and dividing. Don't say it's 103 inches. That's not correct. You have to cross multiply and divide. So it's just using the scale and then plugging in the matching unit. The scale factor is the scale and reduced fraction form. Now, there's two ways to consider scale factor. One of the ways is as simple as just writing it as 1 over 20 using the numbers, and then you could say inches per foot. I'm not a huge fan of that. For me, I think they should both be converted to the same unit so you can truly see how much bigger or smaller it is. Like for me, I would say 1 inch is 1 inch. But I know that 20 feet is actually 20 times 12, or 240 inches. So now I have 240 inches, which is the same as 20 feet. I haven't changed anything, I just converted it. So the scale for me would be 1 over 240. Now you may see it written as just as simple as that, which means this would be 2 to 15 inches per foot. And one other thing to keep in mind is if the scale factor is exactly 1, that means it's going to be the same size. Because if you're multiplying by 1, that's called the multiplicative identity. If it's less than 1, let's say 3/4, and you multiply by 3/4, it's going to get smaller. Multiplying by any number less than 1 makes things smaller. If it's bigger than 1 at all, even if it's 1.5, that's going to make it bigger. Multiplying by a bigger number than 1, because if 1 stays the same, a number smaller than 1 makes it smaller, a number bigger than 1 makes it bigger. You can use your scale factor just based on purely is it bigger or smaller than 1 or equal to 1 to determine if the actual object that you're scaling will get bigger or smaller.